All right, picking up on 25 on your first 9 weeks review. Another word problem. Metal worker wants to make an open rectangular box by cutting equal squares from each corner of a rectangular sheet of metal measuring 12 by 16 inches. Okay, to the nearest cubic inch, what's the maximum volume possible for this open rectangular box? Oftentimes with a word problem, your best bet is going to be to start off with a picture. So if you're given that you have a rectangular sheet of metal that's 12 by 16 and they're going to cut equal squares off of each corner so that they can fold it into a box. So initially this is 16 by 12, but they're going to come in and they're going to cut each corner. Okay, and this they're cutting is a square. They told us these are even squares. Mine may not look like it, just pretend. Alright, so they're cutting these squares off each side so then they can fold those sides up and it's a box with no top. We don't know what they're cutting off, but we said they want this to maximize the volume, so we want to cut off very little, and we'll call that little amount that we're cutting off X. Okay, so X is going to come off every side. Okay, so it's coming off of this side twice on both ends, this side twice, both ends. So what your new length and width actually are, this is actually going to be 16 minus 2x, because we're cutting 2x off of each side, and this is going to be 12 minus 2x. Okay, and once you fold that up, the height of your box then will be x, because that's the length that we cut. So you would have a height of x. So volume of a rectangular prism is length times width times height. And we said our volume, length is 16 minus 2x, width is 12 minus 2x, and height is x. So here's our equation, and we want to find the maximum volume. We want our v, or if you look at this as y, we want our highest y value for this equation. So what you're going to do is go into your calculator and type this in. So in the calculator, in y equals, okay, I've got it typed in a different order. I have the x first. It really doesn't matter if you have all three terms. So we have x, 16 minus 2x, and 12 minus 2x. Go to your table and change it to count by tenths or hundredths. We'll just do tenths, that's fine, because we want to be able to see the values between the integers as well. So in our table we're looking for our highest y value. Okay, so it's still going up, still increasing. Oh, now it's starting to go back down. So we got all the way up to a little over 194, and then it starts coming back down. So around this number is our maximum. Okay, that's not necessarily the maximum, because if you look, it's on both sides, it's 193.95 and 0.45, so it's not exact. So that's not the exact center, but it's pretty close. And if you go back and read the problem, they're asking to the nearest cubic inch. So it doesn't have to be the exact decimal. The nearest whole number is what they're asking for. So back on the calculator, that value, if we say that it's 2.3, 194.03. So 2.3, 194.03. This is our max value. Okay? And this x represents the length we cut off, and this y represents the volume. So this is our max volume. And they want us to round to the nearest cubic inch. So that would round to 194 cubic inches. 26, this is a division problem. You can do long division or synthetic. but I'm going to do this as synthetic since that seems to be what most of y'all prefer. So the first thing you do is find your root. If we set this equal to 0 and solve, x is -10. That's what comes out here. Then you list your coefficients from in degree order. Highest degree is x cubed, so that coefficient is -1. X squared is not here, so you need a placeholder of 0. 75, -250. Draw your line. The first one comes straight down. Okay, when we multiply, we get a +10. Add +10. Multiply -100. Add -25. Multiply +250, which leaves us with a remainder of 0. Okay, we started with cubed, so this is now squared. So this is -1x squared plus 10x minus 25. This can be factored further, so you need to factor it. Before I factor it, I never want a negative x squared term, so if I divide everything by -1, that changes all of the signs. Okay, so that's what I'm going to do before I factor this farther. So x squared splits to x and x. 25, the multiples of 25 that add to 10 are 5 and 5. Okay, and I want it to multiply to a positive but add to a negative, so they both need to be negative. So those are your additional factors. And they tell you they should be 2. So even though they're repeated, don't just write it once. It's both of these are factors. It's a factor twice. 27 is combination functions. You're given your f of x and your g of x and asked to find the sum and the difference. So remember, f plus g of x is the same as f of x plus g of x. Okay, so I'm going to have this term, f of x, and I'm going to add g of x. So I'm going to write out all those terms. So f of x is 3x squared plus x minus 3 plus g of x, which is -3 plus 4x plus 5x squared. Combine like terms. Okay, I've got 3x squared, 5x squared, both positive. I have 8x squareds. X's, I have 1x and 4x, both positive, so that is 5x. And last but not least, different color, we have 3 plus -3. Plus a negative is just like minus, so we have 2 -3's, which is -6. Okay, so that is the sum. So that's the first thing they asked for. It's right here. Now second, they ask for the difference. So that's f of x minus g of x. The only difference here, we're still going to write our f of x and our g of x out. But since it's a minus, the minus will change the sign of everything in g of x. So you need to write out that second one in parentheses. So we have 3x squared plus x minus 3 minus, now g of x is going in parentheses, -3 plus 4x plus 5x squared. Okay, now that negative is going to go to everything in here. So all of those signs get changed. So I still have 3x squared plus x minus 3, and now I'm distributing here the negative to all the terms inside. So that gives me plus 3 minus 4x minus 5x squared. Now I can combine like terms. So my x squareds are 3 minus 5. So that's negative 2x squared. My x's are x and minus 4x. So that is minus 3x. And your constants are 3 and negative 3, so those cancel out, so you have no constant left. So this is your difference. That's what they asked for here. 28, this is also a combination function. It's multiplication. You can write this as f of x times g of x. Okay, and they give us our f of x function and our g of x function. So f of x is 25 minus x squared times g of x, which is 5 minus x. Now, this is simply algebra 1, where you need to FOIL. So remember, that's first. So 25 times 5. Outer. It's negative 25x. Inner. Negative 5x squared. And last, positive x cubed. None of these are the same terms. We have a cubed, a squared, a linear, and a constant. So I can't combine any terms. But before you box in your answer, always list your terms from highest degree to lowest degree. So it should be x cubed minus 5x squared minus 25x plus 125. So that is your combination function, f times g of x. 29 is now dividing f and g with a new f and g. So again, this is f of x divided by g of x. So my f of x function is 1 over x over my g of x function, which is x cubed. Do not stop here. We do not want fractions in fractions. So to get rid of this denominator, okay, we can multiply by the reciprocal. So instead of dividing by x cubed, we can take 1 over x times 1 over x cubed. So instead of dividing by x cubed, I'm going to multiply by 1 over x cubed. Multiply across, x to the 4th. Okay, because we don't like the fractions in the fractions. 30, you need to omit. We did not get to this. I meant to take it off. I missed that one. We'll do that next 9 weeks.